Today we want to take a look at how to simplify our trig functions. So we're going to be given an expression and we want to try to simplify it down to usually either one number or one trig identity. So let's take a look at our key formulas that we already know. We know the cosecant is 1 over the sine, secant is 1 over cosine, cotangent is 1 over the tangent, or cosine over sine, and tangent is sine over cosine. The first of our rules that we're going to use are the Pythagorean triples. Now we already know that sine squared plus cosine squared is equal to 1. And that comes from our unit circle. And if we take a look at making a right triangle anywhere on our unit circle, if I start at the origin and I want to get to this point, xy, I'm going to travel forward x, up y, and my hypotenuse in the unit circle is 1. So we know that x squared plus y squared is equal to 1 squared. And we know that on the unit circle, to get to any point, x comma y, then since our sine is our opposite over our hypotenuse, and our cosine is our adjacent over our hypotenuse, our x coordinate is our cosine, and our y coordinate is our sine. So now we can go ahead and replace sine squared is y squared plus x squared equals 1. And so we can see from there, I have our first trig function. Sine squared plus cosine squared equals 1. Now from that, we can prove our other two Pythagorean triples, and that is that tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. The way that I'm going to prove this is use our rule that we know up top. So I'm going to replace our tangent and our secant with sines and cosines. We know that the tangent is sine over cosine. So if I have tangent squared, I can replace that with sine squared over cosine squared plus 1. And we want to figure out, is this equal to the secant squared? Well, if I take a look at sine squared over cosine squared plus 1, I'm going to go ahead and make this all one fraction. So I've got sine squared over cosine squared plus 1 over 1, and we want to know, is that equal to secant squared? So I've got a common denominator of cosine squared, so I'm going to multiply by 1 by cosine squared over cosine squared. And now I can rewrite this as one fraction. I have a LCD of cosine squared. From the first fraction, I get sine squared of theta, plus from the second fraction, I get cosine squared of theta. And we just discovered, or we reviewed, that sine squared plus cosine squared is 1. So I can now replace this numerator with 1. And if I have 1 over cosine squared, that in fact is equal to secant squared. So it checks out, and now I can use this rule. Tangent squared plus 1 is equal to secant squared. Let's do this same process to prove that our third Pythagorean triple identity works as well. And so we want to prove that yes, indeed, 1 plus cotangent squared is equal to cosecant squared. Once again, I'm going to go ahead and rewrite this 1 as 1 over 1 plus cotangent is cosine over sine. So if I have cotangent squared, I've got cosine squared over sine squared. And we want to see, is this in fact equal to cosecant squared? So just like we did in the first one, we want to find our LCD of sine squared, and I'm going to multiply my first fraction by what it's missing. Sine squared over sine squared. And so now I can rewrite the left-hand side as one fraction. I have my LCD of sine squared, and from the first fraction, I'm going to have sine squared plus, from the second fraction, cosine squared. And notice we have the same thing that happened in our first problem. In the numerator, I can replace sine squared plus cosine squared with 1, and if I have 1 over sine squared, that in fact is equal to cosecant squared, so it checks out. And now I can use my second Pythagorean triple. We wanted to do this process also to help us when we are simplifying our trig functions. One of the easiest ways to do that is to replace your trig functions with all sines and cosines. So let's take a look at doing that with number 1. If I have a bunch of trig functions being multiplied together, then what I want to do is I want to go ahead and replace them with sines and cosines. So for number 1, I can replace my cotangent with cosine over sine. I can replace my secant with 1 over the cosine. And so when I do that, my cosines are going to cancel, and I'm left with 1 over the sine, which is the cosecant. Number 2, I want to do the same thing, but I see that first fraction of sine over cotangent, and I could find a common denominator of cotangent, but instead, I'm going to go ahead and simplify this first fraction first. So I'm going to take this guy, and I'm going to rewrite this as sine of theta over the cosine is cosine over the sine. And so I know that if I am dividing fractions, my first fraction stays the same. And I'm going to flip over my bottom fraction. And so that's going to give me a sine squared over cosine. A little bit easier to deal with. So now I can rewrite this as sine squared over cosine plus cosine over 1. My common denominator is going to be cosine, so I'm going to multiply my second fraction by cosine over cosine. And I now have a common denominator of cosine. From my first fraction, we've got our sine squared, plus from our second fraction, cosine times cosine is going to be cosine squared. I can now replace my numerator with 1. And if I have 1 over the cosine, I have the secant.